Hello everyone, today we are going to do class method. So let's start by doing this class method. So let's start. Let's do this. See, let's start by class methods. We will learn today very much properties and everything, the decorators. So let's start. Methods of objects where we have looked at so far are called by instance of a class. So let's see an example. Let's say we make a class. Let's say we make a class and the class is name is rectangle. Oops. The class name is rectangle and let's start. So this we define a function in it is an instance of it and it takes, so this is width and height. So now we show that self dot width is equal to width itself and self dot height is equal to height itself. So let's define another function. So define calculate area which takes one argument, only self. Then we return self dot width times self dot height, and now we use the class method decorator @class method. So this is the class method decorator, this is the class. Let's do it. Let's define a function. New square. It takes CLS as its argument and side length. So and now it return CLS. CLS is also known as the class. Return CLS of side length, comma side length. So now let's see what's the error, and now let's do it. We have to do it like this: underscore side length comma side length. So let's say square equals to rectangle is a class, and we do it dot new square of 5. Print square dot calculate area. Let's see if we did any mistakes. @class method invalid syntax. Return we have to do return, and now let's run it. It runs 25. It's a new square, so 5 times 5 is 25. So this was correct. New square is a class method and it is called on the class rather than on the instance of the class. It returns a new object of the class CLS. So this was one example. That was a good example. Let's comment this out. Let's see now. So we got a lesson or a quiz. So we are given that class person, and we define an instance in it. It takes two arguments, self and name. All classes should have an argument self. It can have many other arguments, and self dot name equals to name. So we know this, and it is given question mark here and another question mark here, and say hi CLS. We define it, and then it prints hi after getting double quotes around it. So now let's see how what they will be. They can be class method, just as we learned it here, and then it can be define a new say hi. So it was correct, this was correct. Class method, and then we define a function say a hi. Define a function say hi. Let's run this. So it runs nothing because we didn't print it. Let's continue. Static methods. So let's do another example. Let's say we create a class pizza, and we define an instance in it is an instance, and it takes two arguments, self and toppings of the pizza. And it's okay, let's see like this. So it gets it automatically. Self dot toppings is equal to toppings, as we know it. So let's use the static method operator. So let's see. At the rate static method Static methods are similar to class methods, except they don't receive any additional arguments. They are identical to normal functions that belong to a class. They are marked with the static method decorator. So let's define another function, validate a topping, and here we take an argument topping. If topping is equal to pineapple, not double E, is equal to pineapple, then print or raise value error, and say no pineapples. Okay, let's else will return true. True is truth. So let's see that ingredients is, let's say, is it equal to a list of many strings. Let's say is this. Let's say first is cheese, and the second is onions, and the second is nothing or spam. If all returns true if bool x is true for all values x in the iterable. If it is all true, then it will print this what we need to print. So all pizza dot validate topping with the function I in it for I in ingredients. So now it's a function if pizza is equal to pizza ingredients. So let's try it now. It prints nothing, so that means it should be correct. Now if we call the pizza for pineapple, let's try it. It's nothing. If we say print pizza, let's try this. It prints pizza object at this. So this is so done. And let's do another one. Let's just comment this out. Let's do properties. Let's do a docstring properties. So let's start properties. Properties provide a way of customizing access to instance attributes. They are created by putting the property decorator above a method. A property decorator like this, we did it over here. This is a decorator, static method, and class method is a decorator. Similarly, property is also a decorator. So let's say that class pizza. So this is copied from here, and from where it is, yes, till here it is similar. Let's copy and paste it over here, and let me just comment this out. So if top, then we use the property decorator, property attribute function to be used for getting an attribute value or setting an attribute value, and in it we define pineapple allowed self, return false because pineapple is not allowed. And let's say pizza equals to big pizza, or the class with two arguments, cheese and tomato. Print pizza dot pineapple allowed, and let's see if pizza dot pineapple, pizza dot pineapple allowed equals to true. This is equal to true, and let's try to print it. Can't set attribute. Pizza dot pineapple equals to true. Can't set attributes to it, so this was false. And now let's print this. It prints false because this is false as we said it. So we got a exercise. Let's comment this out. And do an exercise. So it's given that a class person and we define an instance in it with these are called unders, with two arguments, self and age. Self dot age equals to int age because it's an number value, so that's why it converts a string to an int. And now it's given a question mark, and define is adult. We have an argument self. If self dot age is greater than 18, and then another question mark.